portion of the GLOS program grant. And Guy Meadows over there is the designer of this buoy. Guy's from University of Michigan, so a collaborative effort between Michigan Tech and University of Michigan. We're going out to deploy a GLOS buoy. That's the Great Lakes Observing System buoy. It's the MTU buoy. It's a 600-pound buoy designed by Guy Meadows at the University of Michigan, and he's up here helping us deploy it. And it will measure how many variables? 20 variables out there. Meteorological variables from the top portion of the buoy, and then it has an underwater component too that measures temperature, conductivity. To be determined. We're going to add some additional probes on it. And this is the test. We're going to put it out North Entry, about 2 miles out, northeast of North Entry, in about 22 meters of water, and test how it does in Lake Superior. Now it's an NDBC buoy, and so the data stream from it can be publicly accessed. So you can Google it and call up the data as part of the NDBC program. It's designed to give us detailed measurements of weather and of temperature. It has about 3 functions. One of it is to enhance the coastal portion of NOAA's monitoring program. NOAA has a whole series of deep water buoys which you can also access the information from. This is the beginning of an extensive coastal series. So it's near shore, and the near shore region is much more sensitive to variables such as water temperature that are associated with global climate change. So one thing is to monitor in detail variables to test whether or not we're getting effects from global climate change. One thing is weather monitoring, is extending the deep water buoy system into the coastal waters. Thing is to detailed check on temperature changes, and that's to look at global climate change variables. What's the temperature of the nearshore waters? How is it increasing over time? We have evidence in Lake Superior that's increasing between 2 to 4 degrees the last 15 years. And the third thing is to monitor pollution, rivers, streams that dump into the coastal environment, and the nature of the potential contaminants. Here we'd be looking at, for example, the drift of the stamp sands onto the beaches, and some of the variables here, wind speed, wave conditions, will be put into a large-scale model of Lake Superior, 3-dimensional hydrologic model, and that has particles, and it'll give us some idea to what degree the stamp sands have particles are drifting along the shoreline, and some prediction as to how much they're going to cover in the next decades. This one as a test in the water until late September to mid-October, and we'll just decide on weather conditions when to pull it.
Nice lights.
We really don't want it to be bound up in ice. That's a concern.
Yeah.
Before, to access information of this type, you'd have to call up the buoy or the monitoring station at Standard Rock, which is about 50 kilometers off to the tip of the Keweenaw. Or there's a deep water one that's about 50 or 60 kilometers to our west. So this brings it really close home, and will allow us to. It should be really used for the Coast Guard and locals to get an idea of what the conditions are right along the coast here. This is part of a large, long-term project that we started, and it really began last year for Tech. But this year, there's been an infusion of additional funds, $1.4 million for the entire project. And as part of that, Guy is deploying a number of buoys around. So it'll be a large network that then can be called up by the public. It gives us money for construction of and deployment of the of the buoys. We also have instrumented the Ranger 3, so as it goes back and forth, we're pulling temperature measurements and conductivity measurements, a whole lot of variables from the. Well, it's really large ecosystem research on Lake Superior. It's being really extending the program. We are having a construction of a new building. That's a Great Lakes Research Center here at Michigan Tech, and this will be one of the major programs.
Yeah.
And it'll be coupled with remote sensing too, and global climate change that we're looking at. One thing is the increase in temperature in the nearshore. There's 2 to 4 degrees centigrade increase here. And this is one of the largest increases in the Great Lakes. Even though it's the northern lake, it's one of the more sensitive. It's thrown off fish spawning. I mean, these warm periods that we've got in the last 15 years are really making it difficult for the fish to cue in on what's the right time to move into spawn. We have faculty that are working on this with sturgeon, Nancy Auer in particular. Everything is, she's been monitoring it for a number of years, and she gets intermittent runs of fish, and a lot of the fishermen are aware too of intermittent runs of steelhead, and it's partly related to these warm spells that we've been getting. Well, yeah, it's also connected up with invasive species. As the temperatures get warmer in the nearshore, there's more chance of invasive species coming over from Duluth, from the no-bob discharges. And we are studying a number of them around here. And perhaps the ones that we're most concerned about are the ones that are starting to arrive at Isle Royale, and they're the zebra mussel and the quagga mussel.